Hello everyone, I'm Felipe, and in this episode of iOS Quickstart, we're going to talk about this new development paradigm that's being adopted more and more by the Swift community, the protocol-oriented programming. Let's do this. If you learned to code in the last few decades, the development paradigm that you probably use every day is object-oriented programming. This is currently the most used method worldwide. In 2015, Apple introduced Swift, and with it, they started suggesting a new way of thinking about their system architecture. Let's take a deeper look at what protocol-oriented programming is all about. Before we look specifically at protocol-oriented programming, we have to understand why Apple decided to push it. And to get there, we have to learn about some of the issues with object-oriented programming. When planning what would end up being the Swift language, Apple engineers looked at Objective-C and had one objective in mind: how to make this better. One of the issues they decided to solve was language safety. How would they prevent that developers end up accidentally creating traps that might be a problem in the future? With that in mind, they decided to attack a low-hanging fruit and one of the biggest causes of bugs in the Objective-C code: implicit sharing. If an object A contains a reference to an object B and passes this reference around, it starts sharing it implicitly. The object that passed the reference to others might end up facing undesired consequences of changes made to the referenced object outside of its scope. In this example, both persons have a reference to the name John. So, when we change the name of the person to James, person 1's name also changes. Can you see the issue here? This could be a nightmare if not managed well. Another issue with passing reference around is that you could have many problems in a multi-threaded environment. For example, race conditions. The Swift engineers figured out that the easiest way of solving all these problems was to use structs. The reason for that is the fact that structs are passed around by value. This prevents implicit sharing. That's why all value types in Swift are structs. This includes strings, integers, doubles, and others. Now you might be thinking, okay, let's use structs then. But what about inheritance? And yeah, that's a good question. In fact, structs do not support inheritance like classes. But if you think about it, even classes have inheritance limitations. Neither Objective-C or Swift support multiple inheritance. To achieve a similar behavior, and possibly a superior one, those engineers decided to start using protocols. This was what created the concept of protocol-oriented programming, aka POP. To go deeper in this topic, let's first discuss what is a protocol. Protocols are a very important concept on the Objective-C language and are extensively used when programming for iOS. The function of them is to provide a list of methods that whoever chooses to adopt it may have to implement. Imagine that they work like a contract between two parts. Whatever class signs that contract will have to implement the mandatory methods of the protocol. In Swift, protocols became more powerful and started taking more of a central role in how the language is used. Because Swift was built using protocol-oriented programming, protocols became more powerful as the language evolved. They got out of a side role to become one of the main actors. In Swift, protocols are really versatile and can be adopted by classes, structs, and enums. Because of its characteristics, they make the act of adding behavior to types an easy task. In Swift 2, Apple gave the developers the power of extending protocols. This transformed the way we use them because now it is possible to add default implementations to them. Add some use of generics on top of that, and you have a very powerful tool to generalize behavior, maintaining code consistency. Now that we know what protocols are and what we want to achieve with them, it's easy to understand what protocol-oriented programming is. In Swift, Apple suggests that we apply this paradigm like this. First, start using structs instead of classes. This would prevent implicit sharing and would help maintain value semantics. Second, use protocols to add behavior to those types. After the version 2 of Swift, we can add default behavior to protocols, and this way we can use those as building blocks to achieve the intended behavior. Third, extend those behaviors. With protocol extensions, we can easily add additional implementations to existing protocols. Now that we understand what POP is all about, let's see it in action. Let's say we want to represent an apple and a pineapple. Normally you think on a structure like this, where both classes inherit from fruit. But this video is all about protocol-oriented programming and how Apple suggests we apply it, so let's start with implementing them using structs. Now, instead of having a superclass, we can implement a protocol fruit. In this protocol, it determines that every fruit has a color, so any struct that adopts fruit has to return its color. Here's how they will be after conforming to that protocol. Now, for a bit of fun, let's create another protocol called pen. Every pen needs to implement the method draw. Now, let's adopt these methods on the structs. Now we have apple pen and pineapple pen. To finish this, it's fair to say that every fruit has the potential to become viral on the internet, so let's add this to the fruit protocol. Now that every fruit can become viral, we can say that fruits that are also pens definitely become viral. To add that logic, we can use a protocol extension. In this extension, we are adding a behavior to the fruit protocol. This is a conditional behavior, and for this reason, we use the where clause to determine that only fruits adopting the pen protocol definitely become viral. Now every time a fruit is also a pen, it will become viral. Let's just stop for a second to realize what we just did here. Instead of creating a hierarchy where both classes inherit all the behaviors and characteristics of a fruit, we now have different structs that can have any behavior added to them. If tomorrow we decide, for some crazy reason, that a pineapple is not a fruit anymore and is now a vegetable, this can be easily achieved without losing the characteristics added by the pen protocol. That's the power of protocol-oriented programming. Let's recap what we saw in this video. In the minds of people responsible for Swift, using classes and object-oriented programming can bring some problems to the codebase, like implicit sharing. To solve those issues, they started using structs with POP. They built a language in a way that copies of structs are incredibly cheap, and this way started using it instead of classes. This solves the issue cited before, but what about inheritance? For that, we use protocols. In Swift, protocols are stronger and can easily be a way to add any behavior to structs. With modern versions of the language, protocols can now contain default implementation of methods and can be easily extended. By using POP, you can generate a set of different behaviors to protocols and use them to piece by piece create your own data structures. That's all I have for today. I hope you enjoyed this brief explanation of protocol-oriented programming. While studying to make this video, I watched a very interesting talk about the subject from Natasha Murashev. I hope I'm pronouncing her name correctly here, and I recommend you watching that. I'll leave the link to that, all the material used to make this video, and a playground containing the code showed here in the description. If you want to know more about MVVM pattern, check out my previous video clicking anywhere on the screen. If you liked this, let me know by liking this video and subscribe for more content. Thanks and good coding!